Hey tech enthusiasts, welcome back to Tech Wisdom, where we dive deep into the world of technology, data science, and artificial intelligence. I am Kshitija, and in today's video, we are going to explore something fascinating: how to analyze emotions in speech using a deep learning model. And here's the best part: I'll be adding the complete code of this project in the description below, along with the dataset link so you can download it and follow along. We'll be working with the Torrent to Emotional Speech set, also known as the TESS Dataset, so let's get started. First things first, we need to download and prepare our dataset. We'll be using Kaggle's Torrent to Emotional dataset. Once downloaded, we will unzip the files and organize them into paths and labels, which will be crucial for our analysis. Don't forget to check the description to the dataset link so you can easily download and set up the data on your own system. This step is all about setting the foundation, so make sure to follow along. Then we will import all the libraries we needed: NumPy, Pandas, OS libraries, and Matplotlib, Seaborns. And just like that, our dataset is loaded and we are ready to go. The length of the path is to 2800. The paths, first five labels. Now let's create a data frame to manage our data more efficiently. We will store our file paths in one column and the corresponding emotion labels in another. This will make it easier to manipulate and analyze the data as we move forward. Before diving into the analysis, it's always good to visualize the data. Here, I'm plotting the distribution of different emotions in our dataset. This helps us to understand the balance of our dataset, whether it's eventually distributed or if some emotions are more prevalent than others. The screen shows the code for wave plot and spectrogram functions. To get a deeper insight into the audio data, we will define two key functions: one to plot the waveform of the audio, and another to display its spectrogram. These visualizations will give us a better understanding of the characteristics of each emotion. The screen shows the code for visualizing different emotions. Emotions like fear, angry, disgust, neutral, sad, PS, and happy. Now let's put those functions to use. Load all audio samples for various emotions like fear, anger, and sadness and visualize their waveforms and spectrograms. This will allow us to see how different emotions impact the audio signal. Moving on, we will extract the mel frequency substral coefficients or MFCCs from our audio files. MFCCs are crucial features in speech processing, capturing the temporal aspects of the sound. We will use these features as inputs to our deep learning model. The screen shows for label encoding. Next, we will encode our labels into one-hot vectors. This is a crucial step before feeding the labels into our model, ensuring that the output matches the format required for categorical classification. This shows the one-hot encoded labels. Now for the exciting part, building our model, we will be using a long short-term memory network or LSTM, which is particularly well suited for sequential data like speech. Our model will consist of several layers, including LSTM units, dropout layers, dense layers to handle the classification. With our model in place, it's time to train it. We will split our data into training and testing sets. Then fit the model and watch it learn. This process may take some time, but it's worth it when you see those accuracy numbers improve. The accuracy of our model is 96.79%. And there you have it, our model has been trained with an impressive accuracy score. Finally, let's visualize the training process by plotting the accuracy and loss over the epochs. Helps us to understand how well our model is learning and whether it's overfitting or underfitting. And that's a wrap. Today, we took a deep dive into analyzing emotions in speech using deep learning. From loading the dataset to building and training an LSTM model, we covered it all. Don't forget to check the description for the complete project code and the data link. It's all there for you to explore and experiment with. If you found this video helpful, make sure to hit the like button and subscribe to Tech Wisdom for more tech insights. Don't forget to leave a comment if you have any questions or suggestions for future videos. Thanks for watching, and I'll see you in the next one. Thank you.